Since we have already analyzed our structure and we have the forces from the analysis as reactions in the base of our columns, we're now going to design and analyze its foundation. For that, we've been working this entire time at the structure tab, but remember that we have two tabs inside 3D. So here in the bottom left corner, we find the possibility to choose Foundations tab. In the Foundations tab, right away we find the 6 starts of the 6 columns that we have in our model. And the first thing is to comment on the general data options. These general data options are specific for the foundation elements. So here we find the possibility to set the material for the foundation elements, meaning the pad footings, the pile caps, and the strap and tie beams. So this concrete or steel that we can choose here is for those elements, although there's a possibility this is the materials that the software will use by default, unless in each one individual element we choose to have different materials for any reason. So by default it will take these materials. Then we find foundation soil, so the possibility to activate the verification of the sliding of the footing. The allowable soil varying pressures. Here we find an errors, that means there are project values, typical values that we will find if we don't have a geotechnical study, but we know sort of what type of soil we have. Then we can click here to help us say the allowable soil vary pressures. In this case I have selected hard clay. Next up are the possibilities for piles, reinforced concrete. I will talk about them later on in this video, so let me skip them for now and we move to the last option in the general data foundations, which is the possibility to consider or not the wind and earthquake combinations in the analysis of the foundation. Next is the options. So here you're gonna find things like the possibility to change the cover for each element, the steel leftovers, the possibility to establish blinding concrete, the code check for cracking in footings and strap and tie beams, and other possibilities of each individual element that we can insert. So for example, for pad footings, we find general settings for the width increment, the apply or not the reduction to flexure minimums, the possibility to place or not a top reinforcement flage even if it's not needed. Different types of reinforcement for the parameter, types of footings for each type of footing that we will insert now, stiffness criteria, pressure increment. So each element that we are now going to comment how to insert has its own options, and they're in this options menu. So what types of foundation elements can we insert? Well, that would be reinforced concrete footings, mass concrete footings, so without reinforcement, just mass concrete, pile caps, tie beams, strap beams, so with the ends balanced, or a beam that automatically detects whether the ends shall be balanced or not. So starting in order, we're going to start commenting on the reinforced concrete footings. They can be either square footings. Let's insert it to see the difference. So square footing will have the x and y dimension, same dimension, square footing. Next up is center rectangular footing. So x and y dimensions can be different, but the column is always centered in the middle of the footing. And next is the eccentric rectangular footing. I want you to please pay attention to the symbol that comes up. I'm gonna display a slide so we can better understand. There's a little symbol that comes up whenever I'm about to insert an eccentric footing that lets me know and by taking a look at the small square that is inside the bigger square, what is going to be the final position of the column in the footing. So if I come closer to this node, I can see that if I leave it like this, the column is going to be placed in the upper right corner of the footing. So if I click, that is where it's going to go. Other types of footings are tapered square footing. Again, rectangular centered but tapered. Or eccentric rectangular taper footing that we can choose. So we can take a look at the difference of the elements that we have inserted so far. They're all reinforced concrete footings. It's just that we have chosen it to be square or rectangular but eccentric, or these other types of tapered footings. Let's delete these ones that we have inserted. By the way, I'm going to cover all the possibilities, so I will at some point point out when we have to insert our real foundation. So feel free to follow along the example of the coverage of all the possibilities, but I will, if you would rather just watch, and I will point out when we have to insert our footings, our foundation. So in the next option, which is mass concrete footings, that is very similar options to the reinforced one but without reinforcement, I want to point out that it was possible also in the reinforced concrete footings that we have the possibility to do with single start or with multiple starts. So this time, since without reinforcement is a little bit more boring, I'm going to insert it with multiple starts. I'm going to select center rectangular footing, and this time, instead of choosing just one start, I'm going to click in this one and also this one. So when we have multiple stars selected, to confirm the selection, we do it with the right click. And since I have chosen centered, even though this symbol comes up, even if I think I'm going to insert it eccentric, I said it was going to be a center one, so it places it center. If I wanted it to be eccentric, I will have to choose here eccentric rectangular footing. And this time, when I go about inserting it, if I choose it to be at some place exactly eccentric, it would insert it like that, respecting our selection. Let's delete these footings and go to our next element, which is pile cups. So in pile cups, we also find single or multiple starts, and we have pile cups with 1 up to 7 piles. Or we have these two other options of strip pile, in which we can choose the number of piles, and this other one, rectangular pile cup, that also is rectangular, but it lets us choose the number of piles in each direction. So now, right now, we're going to select, for example, pile cap for 3 piles, and we're gonna comment on these 2 options. So there's 2 options for piles, this pile generic and pile reinforced concrete. I'm gonna show a slide to comment on the differences. And the differences are that pile generic has been around for a long time in the software. This is the previous option that we had, and it checks the pile cap, but it doesn't check the pile except for its carrying capacity. So this type of analysis of pile generic, it will only carry out the checks for the pile cap, and it will carry out only one check for the pile, which is its carrying capacity. On the other hand, we have pile, the new option, it's called pile reinforced concrete, and it checks, of course, the pile cap, but it does have 3 new modules for the calculation of the piles, and that is the calculation of the sinking load, the structural check of the pile, and the lateral stability analysis. This last module is powered by OpenSys. So I'm going to describe both of them, but just know that we have specific webinars speaking about these new modules of pile calculations. So if you write down or search in the browser for pile calculation CYPE, you will be able to find this video where we extensively talk about the new calculation, and also in our website you can find these new piles 2 and 3 modules more detailed information. So what is, now that we know that this first option, pile generic, will only carry the analysis of the pile cap, we have to, in this case, only set a pile. So here we have click to generate a pile type. And here we find type of pile can either be circular or square. We find the possibility to set the dimensions of the diameter of this circular pile. Next up is the carrying capacity. So this is the only check that it does on the pile, and we have to set what is the limit. So for example, let's give it a 100 kilonewton of carrying capacity. If we had somebody else, or we were buying a precast pile, this would be something. So we just need to know that it's not going to exceed the carrying capacity, and that's all we need, and the minimal distance between the X's. So we would have completed the settings for that type of pile, the generic one. What about the pile reinforced concrete? Well, in this case, we will have to both describe the pile and the soil. So starting with the pile, we click here in New, and we give it a reference, for example, P2. And in this, for advanced analysis, the type of pile being between precast driven or on-site concrete pouring is important for the sinking load calculation. So in this case, I'm just going to leave precast driven, selection also circular or square, diameter, and here is where we set the materials for the pile. So previously in the general data we found possibilities for the materials, but that was for the actual pile cap or the footing, but the concrete and the steel for the pile should be described here in this point, at this point. Then we will have to select the reinforcement, longitudinal and transverse, and the cover for the pile, and accept. And now that we have a type of pile, we will have to set the length of the pile, which we can see here with this question mark help, and the penetration of the pile inside the pile cup. So let's give it a length of 6 meters and 10 centimeters, although this is not our final foundation, so don't insert it yet if you're just following and watching. And here in soil, we're going to insert a new type of soil. We're going to call it soil 1. And we would have to add the different layers of the soil. So by clicking in add, we can click add again, and we can give it a reference, for example, layer 1. Or if we already know the type of soil, we can give it another reference and fill up the parameters if we have the geotechnical study. But what if we don't? Well, the software comes with this arrow, so it's project values, usual project values. So we could right away start inserting, for example, the top layer. I'm going to select that is gravel and click accept. And we just have to give it thickness. So for example, 1 meter of thickness in this layer. Next, because our pile goes depth of 6 meters, I have to complete the soil somehow. So I'm going to this time select, for example, hard clay and click accept. And this time I'm going to give it a length of thickness of soil of 5 meters. And next layer, maybe I can add, for example, a limestone, and this I'm going to set 1 meter. So like this, we could complete our layers of the soil, and we could choose to export this soil to the library for it to be available for other elements in the same project. So I'm going to click accept, and now that we have a pile cup with piles that are reinforced concrete, we just have to choose the type of pile cup. And this to the left, we said that it was only going to check the pile cup. So let's demonstrate. I'm going to click in this node 3, and I'm going to ask it to design. When I ask to design, the software will run either a complete design, both the geometry and the reinforcement, or I can set up some geometry right here. We could have inserted manually the overhang and the depth, and it will search out for the minimum dimensions. If necessary, it will increase our dimensions, the one that we gave, but it's never going to set less than we manually established in the geometry. And the last design option would be not changing and modifying the geometry, but designing just the reinforcement. So I'm going to ask it to run a complete design of this pile cup to see that this was the first option, generic. So it's only giving me checks of the pile cup. For example, here says that the interaction between the piles, that we have established a meter of separation and that it should be more, so we could change it. The only check that has run for the pile cup is this pile capacity. Okay, we established the limit, and it has checked what is going to be the carrying capacity, and it is less than the limit that we established. So how could we change now that we have inserted, how can we change the materials, for example, or that separation that you gave? Well, materials for any individual element can be changed here in materials. So even though we have set in general data some materials, here we could choose that this pile cup is another type of concrete. or another type of steel for the rebar. Also, here in piles, we have the possibility at any time to change the type of pile, or in this case, the distance between the piles. And I'm going to have here accept. And if we check now, this interaction between piles is checked. And it's more than it is and that the necessary. So that is the design option that we have for this generic pile. We can ask for here in Strat 3D, we can consult the model that the software is using for those code checks. So we could check the reactions in the base of the column, but we can also check for by combination the actual force and the moment in X and Y that it's going to have for this model. Let's now check, because this one, okay, it's not going to design the piles. It's just going to stop at the design of the pile cup, but we inserted that other option with the new modules. So let's check out the results. If we edit this other pile cup, we can ask again for the design complete. In this case, the tip of the pile lies outside the ground that we have defined. Here in piles, let's ask, it has a length of 6, but since it also has a certain depth of the pile cup, we have to consider that maybe this up to 7 meters was too little. So let's say that the limestone is covering the next 5 meters, and this shall be enough. So we are going to now click on design again and complete. And check here in code checks, we can see that it has not only run the checks for the pile cup, but also for the piles, and it runs the sinking and load calculation. It runs some checks for the structural check of the pile itself, and if it were needed, it would point out that the lateral lateral stability analysis should be carried. In this case, it's not pointing it out because the moments are balanced, but if we had inserted, for example, this other type of pile caps where they were all in a strip, probably it would point out that the stability is needed. So let's see if with this strip design we can have that check pointed out. In this case, it points out that it has not been able to balance the bending moments. So it says either insert strap beams or analyze the lateral stability of this pile. That would be activated by coming back to the general data. And here we will find in these piles options that I skipped earlier, we find the possibility to activate the lateral stability analysis of the pile. And by that activated, it will run that third analysis, the complete analysis. And the geometrical parameters have not been defined because for that lateral stability, we need to define in the soil that we defined. We have to say for each layer what is going to be its PY curve. So again, we have to either obtain this from the geotechnical study, or we can make use of the values that come by default in the software. So for this one, I have chosen the gravel, and for this one, I come to PY curve and ask for the hard clay PY curve. And for rock, I don't believe we have here. Consider the stiffness for prevents the mobilization of the stuff resistance, or if we uncheck it, it doesn't. But yes, usually rock, it's not going to be mobilized, so it makes sense that limestone is not asking for the PY curve. And now if we design incomplete, as we said, this is a nonlinear analysis, so it's powered by the OpenSys analysis engine. And for this module, it is necessary to have the OpenSys module as well. From this analysis, we have obtained the following results. So we click in Code Checks. And we can consult in the piles here the lighter stability analysis of the pile. Then we can consult the horizontal displacement at the pile head has been X length. So that is it for the piles. We could also have a 3D view of the reinforcement of the pile using this option 3D view instead of the detailing. And now I want to insert a foundation that needs strap beams. So let's insert some reinforced concrete footing that are eccentric and that are according to the position of the column, that is going to be its eccentricity. For example, this, to comment on the tie beam and strap beam. So for tie beam, we said that their ends are not going to be balanced. When we go about inserting a tie beam, for example, this one, I can, or any tie or strap beam, I can select either that the axis of the beam is going to be it's going to go through the center of the columns or the center of the footing. So in this case, I'm going to insert it center in the footing. And we want to also comment on the strap beam. So if I click on strap beam, we can choose from a number of types of dimensions of beams and reinforcements. But most importantly, we can choose whether the ends are going to be balanced at origin or at end. So if I click in both and click, for example, now that it goes from the column to the column, now we can see that I have inserted with both ends balanced. If at any time I want to change that, I have this possibility here called balanced ends to unbalance the end that I click on. The same thing with the non-balanced beam, so the tie beam. It was a tie beam, but if we click here to balance this end, it will ask, do you want to change the type of beam to a strap beam? Even if we say yes, it will balance both ends and we can choose which one to maintain. So with that said, let's try, I'm going to delete these two that I have inserted so far with this option delete, and I click in both beams, and I'm going to insert them all with the other last possibility, which is choose whether they have to be balanced or not. So for example, in the X direction, this footing in the middle is centered in the X direction. So if I choose to insert a beam that would go from this column to this other column, only this end shall be balanced, because in the X direction this footing is already balanced, but it's not, it's eccentric in the Y direction. Y being the vertical direction on the screen. So if I do this in the opposite direction, please notice that if needed, it will be balanced. So this is the last option where the software chooses for us whether it has to balance or not the ends according to the element that we select. And if we let the software automatically design the foundation as I have it right now on screen, which by the way is not our final foundation, but you can go ahead and insert it. Just 6 eccentric footings in each one, and the type beams are the things that we are going to delete afterwards. So if you want to go ahead, as I'm going to now demonstrate the design, please insert eccentric rectangular footings in each one of these columns. So if I click here in design the entire foundation, I can ask it to design only the pad footings or in the pie cups, or also the strap beams. So I'm going to click quick design and quick and complete design and let it come up with a result. So first thing, since we have beams inserted, if I edit it after the design, I can consult the reinforcement and the code checks for the strap and tie beams. Here I have it, and I can also click here on View Complete Report and export it to multiple formats. And please notice that, for example, this corner pad footing has now with the strap beams that balance the ends, it has a dimension of 110 by 110 by 45. Let's delete the strap and tie beams, which are going to be our final. For this little pergola, we are not going to need any strap beams, but notice that the beams did some balancing, and the dimensions that we obtained for this footing were less than if we run now the analysis without those strap and tie beams. So I'm gonna this, by the way, is the analysis that we shall do for our example. So insert these pad footings and run the analysis, and we can see that the pad footing is a little bit bigger than with the strap beams, but we can accept is how the dimensions, so we're not going to have extra concrete on the strap beams for just 50 millimeters in this pad footing. Centimeters, by the way. If we click in this pad footing, we can see the materials used, the geometry, and it's in centimeters. Okay, so this is it for the foundation. This is our foundation, and see you in their next video.